We've played around with tables and graphs, and we've even plugged numbers in to figure out these composite equations or composite functions. But now we're going to look at it just algebraically. What if you could combine those two functions to start with and then just plug the number in once to get your answer? So what we're going to do here is we're using example 4, which is f of x is x squared plus 3x. That's our first function. And our second function is g of x equals 3x plus or minus 5. A asks us to do f of g of x. So if I was plugging in a number, I would plug the number into here, get the answer, and then I would plug that answer into this one. But what they're asking us to do instead is just put that formula inside that formula, get the new equation, and then just plug the number in once. So what we're going to do is write that out. Basically, this is going to be our skeleton equation, and we're going to put this in for every place that there's an x in this one. So I'll start out by writing out, I'm going to give myself lots of room. There's x squared plus 3x. That's our original function, our skeleton equation. But what we want to do is, g of x is actually the x here. So now I'm going to put g of x in every place that there's an x. So you can see that f of x is the outside, g of x is the inside. The same way we've done before, only now we're using algebra. So there's two things I can do. I could actually put this into my graphing calculator just the way it is. But what your book wants you to be able to do is work with the formulas a little bit and simplify it. So for this one, I can actually write out 3x minus 5 times 3x minus 5, because that's 3x minus 5 squared. Plus, and I can just run right through the brackets here, 3 times 3x is 9x, 3 times negative 5 is 15, negative 15. So now I can simplify this one, 3x, I FOIL it, 3x times 3x is 9x squared, outside 3x times negative 5 is negative 15x, negative 5 times 3x is another negative 15x, and then negative 5 times negative 5 is plus 25. Then I've still got these guys here, and now I just collect my like terms. I only have the 9x squared, there's no other x squared, so that's fine. This is 30x, negative 30x, plus 9x. So if I've got negative 30x here and positive 9x there, I'm going to have minus 21x for my total. And then I've got positive 25 and negative 15, which will give me positive 10. So here is my simplified formula, and if I put this into my graphing calculator, it should look the same as if I plugged all of this into my graphing calculator. And that's how you would get the range and domain for this one, is just graph it and read the domain and range off of the screen.